So a broad range of experiences and stories to tell. I'll start off. Who has stories to tell about Portland limestone cement concrete? Concrete made with Portland limestone cement. Who has good stories to tell? Yeah, okay. So who has bad stories to tell? Yeah. So don't hesitate, right? We're going to be honest in this room. We're going to spend a lot of time each other for the next few hours. So don't hesitate to share those stories. That's why we're here. Shared experiences mean we can learn from them and learn what's going right, what we can do to make things go better, and what's maybe not working so well. Okay. So that's really what we're talk about here. And don't hesitate. Very informal. Don't hesitate to ask me a question when it comes to your brain. Don't wait till the end. Okay. Just scream out your question, raise your hand, whatever, and ask it to me then. I'm going to offer this from an industry perspective. Yes, I'm a cement person, and I've been in the cement business and the ready mix business for 16 or 17 years now. And there's other cement producers in this room. So if you have cement specific questions, you have lots of good perspectives in this room to answer those questions. So we'll get them answered. By the end of this day, we'll have all of your questions answered and hopefully give you some knowledge. Kind of an easy agenda, nothing too crazy. If my clicker starts to work, got to turn it on. I'm just going to kind of roughly go through how we got here, right? We got to look at our past and how we got here to know what's going on in the future. And then I'm going to go over what I call my top 5 questions that I get asked most often right now, okay? And how we're thinking outside the box to address those questions. So we all know how we got to the Portland limestone cement world, right? Anyone want to just shout it out how we got here? Right? By the government, right? So that's one of the questions I always get asked too is, why did you cement guys do this so fast? It really wasn't up to us, okay? It was what I call a top pull through kind of strategy. It came to us as, hey, you are going to reduce your CO2 footprint. Here, we want you to be carbon neutral in the future. And here's where you have to start doing it. Okay. And I will also say that I somewhat blame the Amazons of the world, the Googles of the world, the Microsofts of the world that are putting up huge data centers and huge complexes. And in their specifications, they're now writing in what we call global warming potential CO2 footprint numbers. Okay. And they will tell a producer that says, I can't use your concrete unless it has a global warming potential of this number or below. And the only way to get there is to use materials that have lower CO2 footprints. Okay. Cement gets a really bad rap for producing a lot of CO2, which you'll see these numbers up here. 90% of the CO2 footprint in your concrete is from cement. Okay. We're a CO2 heavy business just by our operation. But you can see overall, in the grand scheme of things, concrete is only 8% of the CO2 produced globally. Okay. But we use so much concrete that we get a bad rap. What is the number 1 used material in the world? Water. What's number 2? Concrete, right? And I always think it's funny because we use so much water in concrete, right? So it kind of is a catch-22. Maybe concrete should be first, right? But that's why we get a bad rap, okay? And like I said, cement is a CO2 heavy business, okay? Just by the process of how we make it. So that's kind of how we got here. So I don't want y'all to think that us cement companies, we got together in a room and said, hey, this is what we're going to do to make everybody's life hectic. I promise we didn't do that, okay? This came down from above our heads. So another funny thing, over 200 years ago, what we consider the modern day Portland cement was patented. And actually here in Kansas, we have some of the oldest remaining structures from U.S. production for cement. It's actually kind of cool. But at the turn of the 20th century, the early 1900s, ASTM was established where we kind of hold our specifications for cement now. Okay, so ASTM C150 was where the type 1-2 used to be. And besides some slight modifications to, maybe set time or blane or these kind of things, it really has been the same since the early 1900s. Okay. So we have seen more industry change in the cement world and hence the concrete world in the last 100 years than we'd seen, or in the last 3 years than we'd seen in the 100 years prior to that. So it's been a really fast changing time. And I always tell people, these are the faces I get most often when we talk about how much change is, right? It's scary, it's confusing. And who has been angry with this change? Who's had moments of anger? Admit it. I have them. I've had lots of moments of anger. Joe's had lots of moments. Bobby's had lots of moments of anger, right? For the last few years when we've made this change. I probably should put a smiley face up there because it hasn't all been bad, right? It's been good too. But I understand that it's frustrating. And I always tell people, being an old farm girl, I ran across this ad in a magazine once and I thought, when they went from hand washboards to washing their clothes to a motorized washing machine, it was a huge change in the way we lived our everyday lives, right? And I'm sure there were bumps and bruises and malfunctions and bad things that happened in the inception of that, okay? But they worked through it. And can you imagine going back to your washing machine now that you can program from your phone? Can you imagine going back to doing it on a washboard by hand? No, right? So it might be a little rose-colored glasses of me, but I'd like you to think of PLC that way, okay? PLC is the next step in the evolution of the washing machine, okay? We're going through our struggles right now. It's kicking us in the butt, but it'll get better and will only continue to evolve after this, okay? So try and think of it that way. All right. Quick one step in our process where it changed. Here's the finish mill. It's the very end of our cement manufacturing process. We used to put in clinker and gypsum and limestone, less than 5%. Gold star for who can tell me why we put gypsum in a finish mill. Besides the cement guys, you don't count, you don't get a gold star. Controls the set time, absolutely. So if we didn't put gypsum in a finish mill, you would have what we call flash set. Okay, so you'd have concrete that gets hard in your ready mix truck right away. Okay, the gypsum controls what we call the C3A reaction of the cement. It coats that just long enough so everything else starts to react first, and that fast acting reaction then reacts later, so we don't get flash set. So that's why we add gypsum. Okay, just a fun learning moment if you didn't know about cement. So we used to add into less than 5%. Now we can add up to 15%. Nobody adds 15% because at 15%, we can't manufacture to that tight of a standard, so we'll be out of the spec, right? So that's why you're typically going to see 12 or less is what we see here in Kansas, okay? So that's the process. So into my questions. And like I said, if you have other questions or questions that build off of these, let's talk about them. But these are what I consider my top 5 questions that I get asked most often. Why is my concrete so inconsistent? One load can be good, one load can be bad. Why is it so inconsistent? I have to be getting different limestone percentages. There's no way that those cement companies are sending me limestone percentages that are the same all the time. Okay? That's my probably my number one most skeptical, need to debunk kind of question. And here's what I say. We are a manufactured product. Not all cement plants look the same, but we all still have the same flow, okay? We all still really have the same steps in our process. And although we all might sample differently, we sample continuously. We have employees that all they do is go out into the plant, pull samples, come back to the lab and run them, okay? So if we go through each one of these steps of our process at the quarry, most of us have our own on-site quarries. We sample and test our limestone, okay? For chemistry, for impurities, these different kinds of things. Not all limestone benches are created equal when it comes to chemistry. We sample there, okay? We put that limestone with other raw materials, which get brought into our plant, which get sampled for chemistry, impurities, size, fineness, okay? We grind those together in a raw mill. We make kiln feed. That kiln feed gets sampled, chemistry, fineness. Basically, this process that I'm dictating to you happens at every step in our process throughout the day. Like I said, we run 24/7, and that means we have shift guys on 24/7 that all they do is pull samples and bring them back to the lab and run them for different parameters, both chemical and physical. Okay. So our goal is to deliver a concrete producer the most consistent cement possible. Do we have whoopses? Absolutely. I would never admit to you that you don't, right? We all have mistakes, but we isolate that material and don't send it out to the field. Okay. So keeping our limestone percentage consistent is one of our top priorities. We don't set out at the beginning of the day to manufacture something at 8% and then jump to 12% and then back to 8%, right? If those kind of swings happen, we catch it because we're sampling every hour or every 2 hours or every 3 hours, depending on the spot and location in the plant. Okay, so we catch those kind of inconsistencies and eliminate them from our production stream to go out the door. Does that make sense? Also, something was out there recently here in the last year, a study that talked about the limestone fines being smaller than the cement particles and those separating in transportation or that all the times that we move cement. Who had seen that paper article kind of rough home study? Okay. So that came out and that kind of like shocked the cement world, right? This like kind of homegrown study that said, oh, we need to be concerned with that. So at Central Plains, and I know that other cement companies did that too, we went through and did like a traceability study. Okay. From me specifically from my Sugar Creek terminal, which is where my Sugar Creek plant, which is in Kansas City, we move cement lots of different ways. Truck direct, we put it on rail to customers. We go on rail to a terminal to customers. We put it on barges to a rail to customers. We move cement lots of different ways and lots of different times. So I did a study that we started at the plant and I traced that specific cement throughout our process in all of these different transportation modes. And I sampled them, brought them back to the plant and said, hey, what's our limestone content in all of these different parts in our process? And then you can see that no matter our transportation mode or how many times it's been moved from one transportation mode to the next to the customer, at the end of the day, we were relatively consistent. Our target, once again, is 12%. Okay. So we didn't have any big swings that I had a sample that was at 8% and one that was at 15%. Okay. So to that study, I would say, at least for me, I don't seem to have a problem there. Okay. We don't seem to have this separation of limestone and cement particles. So that makes me confident that in that case, I'm not sending cement out the door that's inconsistent from that angle, from a limestone percentage. Okay. Because I'll also admit that 8% limestone at my plant performs differently than 12% limestone at my plant. No doubt. Okay. They have different strength profiles. They have different set profiles, and they're different. So I can recognize that if I sent you two different products like that on the same day, you'd absolutely be inconsistent. But I'm telling you, we don't do that because we sample it so often. Okay. Questions revolving around this question. Go ahead. Yeah, Jerry. Mm-hmm.
And that the old days where you were basically taking all the limestone and tinkering it, that kind of. So, but now you're adding paper.
Right.
So, and the limestone itself is inconsistent, and that's causing some inconsistency.
Yeah.
On how.
Yeah. And I think, Jerry, that's a good question. And I think I touch on that a little bit later here when we talk about some bleed rates, but I'll talk about it now too, because we all know that in our world, our concrete world, not all limestone is created equal, right? We have some that has high absorption. We have some that has low absorption. We have some that have better durability characteristics than others. Some people will tell you that at the micron level that we grind limestone to, those kind of factors shouldn't play a role. I can see that perspective, but I can also see a perspective from, I know that A limestone that has an absorption of 2.8 is far different performing than a limestone, especially when we talk about water demand, is far different than a limestone that has an absorption of 2.4, right? So to that point, I don't think we've fully flushed out whether that is true or not. I think it's an absolute possibility that not all limestones are created equal. And I'll tell you that my limestone at my quarry is different than Joe's limestone at his quarry. Okay. And right now, the only condition that has to be met per ASTM is a calcium carbonate level of so we do have to have a certain quality of limestone, but it's only one parameter. Okay. So I don't think we intentionally put our less design because there's limestone in our quarry we can't use in cement, right? So I don't think we intentionally put that into our limestone percentage. But that's speaking for me. But I don't think any cement producer does that, you know. But not all limestone is created equal. That's absolutely true. How much of a role does it play in the PLC's performance? I don't think we've answered that question, but it's definitely one that needs to be dug into. So I know I'm already dating. I just had a meeting yesterday about that very topic, about across all my networks within Eagle Materials. How do I define who has better limestone versus the other? So I had just had a conversation about it yesterday. So I know we're looking into it, and I know all these other cement producers are as well, because it's a question we haven't fully answered, although some of us has gut instincts one way or the other. I don't think I haven't seen data that fully proves it one way or the other. But good question. Does that answer your question? Joe, do you have any comments on that? Well, we have a little sometimes different opinion. Right.
What's going on? It's so small. The other thing I was going to tack onto that is, just as an interesting side point, it's almost more of a production problem than I think the actual on the receiving end of it, because if you look across the country, and I've talked to different cement companies, you've got different limestones, and there's also different hardnesses.
Right, absolutely.
That's going to affect how it's grinding. And so you may have at a certain plant a production issue of, we've got to do something different than somebody else because of the hardness of the limestone or the efficiency of the
mill.
grind.
Yeah.
So that does affect it, and that will affect particle size distribution.
And that's what, yeah.
I think a bigger factor
then, yeah,
is what the final product ends up being as far as the size distribution.
Right. So the particle size distribution of the cement profile has definitely changed from type 1-2 to PLC, right? We absolutely have these finer sized particles from the limestone, because no matter how hard it is, it's still easier to grind than clinker. Okay. So it's going to be a finer grind, the limestone portion, no matter what, right? And that was really what drives that blade number up. So we've gone from let's just throw out a number, a 380 blade to 420, 430, 440, something like that. Okay. And that's primarily of that limestone portion has driven that fineness up because it's easier to grind. But Joe's absolutely right. Some limestone is harder and it needs more time in the mill. Well, more time we run our mill and don't have throughput, our mill conditions change, right? Too. Our temperatures change, which changes our gypsum phases, which changes a million different things in the final product too. So all of that can be tweaked, and all of that is different from plant to plant. So we're all, learning from that as well, and adjusting and making the correct adjustments there. But good question. What else specifically from cement production? Any questions? Okay, perfect. All right, let's move on. My number 2 question. I just want to make sure what time we are here. Okay, number 2 question. I haven't changed any of my practices, but why am I getting more plastic shrinkage cracks? Why is this happening? Who feels like they've seen an increase in plastic shrinkage cracks? Yeah, a few of you guys. Okay, we have the cement guys. How many more calls have we gotten about plastic shrinkage cracks? Absolutely. Okay. Let's talk about the mechanism of plastic shrinkage. Who watches The Office? Anybody watch The Office? Okay. So two memes that I came across that when instantly I saw them, I was like, oh, made me think of PLC, and I'll explain why. I have a very low tolerance, and Kevin gives you this ugly face. And then boss man over there, he says, you are not forgiven. These two memes sum up PLC. Okay. No sugarcoating it, no waxing of words here. Concrete that has PLC in it seems to be more sensitive. Okay. It seems to be more susceptible to the everyday abuse and rigor that we put our concrete through. Okay. Especially when we come to surface issues. Why is that? I don't know. Lots of theories about that, and we can talk about those too. But 100% full admitted, concrete made with PLC seems to be more sensitive, and we need to treat it as such, and we need to remember that. And I think all the cement producers in this room would agree with you that would agree with me that that's not something. When we tested Portland limestone cement before we rolled it out to you, we all tested it in our labs, and we did test pours, and we did these kind of things. But the sensitivity to field conditions and the sensitivity to how our industry treats concrete in general was not something that we predicted. And we're having to manage and deal with those kind of things right now. Okay. So if we can all operate from the same platform that says, we just know that our concrete now is more or less forgiving than it used to be and move forward, I think that's a good place to start. Okay. So plastic shrinkage, we all know plastic shrinkage happens when we get a drying of the surface, okay, before the rest of our concrete has started to harden. And these actually happen far before and can often happen far before finishing is even done, okay? How many have been on jobs where they're trying to finish it and they're like, it just keeps ripping open. It just keeps ripping open. Show of hands. Absolutely. Okay, that's plastic shrinkage, okay? Why, though, does plastic shrinkage happen? So here's a little diagram. Here's our slab, okay? We all know that we should get bleed water to the top, right? This is how concrete should perform. We should have some bleed water that comes to the top. Who says maybe we don't have as much bleed water as we used to? Okay, that's one of my questions we'll also talk about here a little later. So set that question aside and just say, we should have bleed water to the top, okay? The way that works, it pools on the top, and we also have some bleed water that goes down. And we can talk about vapor barriers and all those kind of good things and some things that are happening right now with vapor barriers in an untraditional way. But we know we should have bleed water at the top. Okay. And we also know that water evaporates. Okay. Whatever the weather conditions are, water evaporates. And when we have sunny, bright days and the wind blows in Kansas, guess what happens at evaporation rate? It increases. Okay. That bleed water evaporates even sooner. All right. And when that happens, we have that disappear from the surface and we create plastic shrinkage cracks. Now, all plastic shrinkage cracks is your concrete telling it that it can't withstand this internal tension. Okay. When our surface dries out, our concrete hasn't built up enough strength to hold back against that internal stress. We all know concrete is really good in what? Compression, okay? But we know concrete's not good when we pull it apart or put it in tension, right? So that's really what's happening on the surface of your concrete. We're putting all of that surface in tension, and it makes these little plastic shrinkage cracks, all right? So here is when our evaporation rate is greater than our bleed rate. Who evaporation rate? Raise your hand. Oh, love it. Almost everybody has raised their hand. That's great. I did this talk last week in a room where very little people actually raised their hand. And I don't know if it's because they were shy, but they were asking good questions, but they didn't raise their hand, and it kind of made me a little nervous. So I'm glad you all raised your hand. So I came across this rule of thumb once about concrete. It says, if we've got less than 10 miles an hour wind, greater than 50% humidity, less than 85-degree concrete temperatures, and less than 80-degree ambient temperatures, ideal day to pour concrete. How many days a year in Kansas can we pour concrete? 3. I see a 3. That's generous, probably, right? 5, maybe. Yeah, exactly. And they all happen on Sundays, right? So none. It's not practical. These situations don't happen, and we all understand that. So how do we combat that? Okay. Here is a list of things that we can do to help combat this plastic shrinkage that we know now that concrete made with Portland limestone cement is maybe more prone to, okay? Maybe more susceptible to. First one, I will go through each of these and some of them more in detail, but the first one, provide a windbreak. How many people go on a job site that has a windbreak? No, right? Doesn't happen. How many jobs have 5 big trucks sitting at them that could be parked in the right direction to create a windbreak? Absolutely, all of you. So I'm just encouraging you as people in the field to do these outside the box thinking, right? Move my truck. It provides a windbreak and maybe it provides late afternoon shade. Okay. Both of those kind of things help with plastic shrinkage. We just have to think, and oh, I didn't have to do this before. I get it. I get it. I get it. All of these tips I'm going to give you, you're going to be like, I never had to do them before. I get that. Okay. But I'm saying we all need to start thinking differently. And this is one of those simple things. Fog the surface. We very rarely see that, but that's still a really great thing to do. Provide shade, also a great thing. Evaporation rates. Know them. Who goes to a job site and knows their evaporation rate on the job site? Anybody? Some of you ready mix guys are probably like, we kind of have some evaporation rates in hand. All right, it's super simple. Buy yourself a, oh, and it doesn't show up there. Buy yourself a handheld, machine that goes out on the job site, tells you wind conditions, tells you temperature, calculates your evaporation rate, lets you know if you're in the danger zone. Okay. There's also apps for your phone, or you could go through the old school ACI graph in 305. Okay. But I would say use the technology at your fingertips to know your evaporation rates. What is good or bad for evaporation rates? So this is taken out ACI 305, which is the hot weather concreting guide. And in there, it talks about when we have evaporation rates of over 0.25, we should be concerned about more potential for cracking. Okay. Below 0.25, less concern for cracking. Don't we like that lawyer language? Be concerned for more or less. Means, it still could happen, but have your antennae up. Okay. Then you'll see some stuff that says strong possibility when we exceed rates over 0.2. And then we have things that say even we should consider it at 0.1. Anything over a 0.1 on your evaporation rate, we need to take these extra precautions. There is lots of discussions at, a national level about these numbers. Are these numbers any longer accurate for PLC, right? Is that 0.2 or 0.25 number really accurate? Should it really truly be 0.1, right? Should it be 0.15 that says, hey, we're going to have severe potential after 0.15. We absolutely need to take these steps. So I don't know what the number is. I'm not smart enough to figure out what the number is, to be frankly honest with you. But I will tell you, I know how to know what my number is. And I know that when I get a number that is increasing, I need to take my precautions. Okay. And I need to go above and beyond what I traditionally had done in the past. Okay. So know your evaporation rates. Really, it's my next one I want to focus on. How many of you are on jobs that cure properly? How many of you are on jobs that cure it all? Yeah, okay. Examples of what you guys do for curing, you two that raised your hand right next to each other there. 14 days of wet burlap. Love it. What else? The row right in front of him. Spray on cure like a wet, like a white cure. Okay. The 14 days of wet burlap, is that a specification somewhere? KDOT, is that? Remind me, I deal with too many DOTs. That's KDOT's specification for concrete? 14 days? Bridge decks. Okay, wonderful. What is KDOT spec for normal pavement? What your mainline paving? What is the spray cure on? Okay, thank you, Jerry. Yeah, okay. What about on all our other stuff? Residential, even some light commercial. Do we see it there? from a ready mix perspective, Geiger MCM guys, what percentage of jobs do you see that get cured? Even commercial, residential, none. That's zero. Yeah, right. Chaz, same opinion. Yeah. Yeah. You speak up again. What'd you say?
Densifying, spraying a densifier on, back rolling it.
Okay.
And then later on.
And later on that day. Okay. Good. What else? Anybody else have any good ones that they seem works for them? Okay. My motto is if it dries, and my clicker stopped working. If it dries, it dies. Okay. Not only does the surface die, but strength dies as well. Right. So that's why we put cylinders in water bath. Okay. So if it dries, it dies is my motto. So there's lots of different curing out there. And I'm not standing up here to say one is better than the other. I am a firm believer in this world. Any curing is better than no curing because we don't do it nearly enough. But there are ways that it can be done properly. 14 days of burlap, if it's left dry, does me no good, right? So those kind of things. Now, outside the box thinking is with the development of PLC and kind of looking for alternative methods. There's some internal cures out there on the market. If you're not familiar with those, absolutely get yourself familiarized, whether you're a ready mix producer or a contractor or an owner specifier, get yourself familiarized with those kind of products. And see if they'll work in your market, or if they're applicable for your market, or if they'll work in your concrete mix. Okay. So there's definitely some integral cures out there, obviously ones you spray on. Couple comments that I've heard here recently. Anybody use a cure and seal, an integral cure and seal, an acrylic one? I have heard that that maybe doesn't last as long as it used to. I heard that in the Kansas City market that some of those integral acrylic cure and seals haven't had the longevity that they used to have. So that's just something to be thought of if you're going to go down that route. But I definitely would encourage you to look outside the box at all of these options that are out there now for curing that are not only topical, but integral in your concrete mix as well. Any ready mix producers use any integral ones that you put in your concrete and deliver in your concrete to the job site? An internal sealer, but not an internal cure. Okay. Great. Anybody else? Did you get positive feedback on the internal sealer? Mm-hmm. One of them had that product in it. Okay, perfect. Yeah, we'll talk about surface issues that we've been dealing with this last spring here in my next question, I think. So that's good insight. But just continue to know that this is an important step. It's always been an important step. We haven't done enough of it nearly in the past, but boy, is it really important now. Okay. And I will tell you that I'm a proponent of having a cure written into a specification. If you've got a commercial job or if you've something like that, put it in a specification. If you're an owner or a specifier, I know I usually am the last one to say, oh, let's make specs require more things. But when it comes to curing, I think it's okay to put in your specification that says, hey, you must cure it. And here's how the plethora of options that you can use, but it must be done. So, okay, a couple bad examples. Like I said, some is better than none. All right. Next one, night pours. We already know we try and do that. Night pours, our evaporation rates go down. We like those kind of things. Redesign a concrete mix. How can redesigning our concrete mix help with some of these plastic shrinkage cracks? Anybody have an idea? To help with this issue? Okay. And another thing I think that I talk about, I don't actually highlight this one, but when we talk about redesigning our concrete mix, this is going to sound silly, but also with PLC, it seems like we get some what I call differential setting through your slab. And how I'll describe that is we get hard on the top and spongy on the spongy below, right? Okay. And that problem increases with the thickness of your slab. Okay. 6, 8, 12 inches, these kind of things, you have a wide variety of setting throughout that thickness. I've had some success with customers that have plastic shrinkage cracks and some issues that develop that says, hey, I'm going to accelerate your mix when you don't traditionally think you need to accelerate it. We all know that we put accelerator in the winter, right? Okay. But we need to accelerate at other times. I talked to an admix guy last week and he told me, he said, Megan, guess what my biggest market countrywide is for accelerator? Anybody want to give me a guess? Texas, that's close. It's not like Wisconsin or Minnesota, it's Arizona. Arizona is where they sell their most accelerator. You know why? Because even though it's hot in the summer, it's also dry and no humidity and windy. And they have plastic shrinkage like crazy. So what they do is they accelerate it. They force that water to the surface even faster. Now, I am not a finisher, nor have I ever claimed to be, but I understand that when you accelerate concrete at 85 degrees, you also need 1 or 2 more guys on the job site. I get that, okay? You don't want it to get away from you. That concept's not lost on me. But once again, I'm trying to give you ideas of thinking outside the box, of doing something different than we've done before. Because what we're doing now is not working, right? We can all understand that we've got jobs that are not working, so we need to try something different. And that's one of those things. Accelerate it across the mix. And I'll tell you from a cement perspective, when I used to focus on 28-day strengths, I'm maybe more now focused on my set times and my 1-day strengths, because I know that I want good setting across their slab. So if I can maybe, shorten my set time just a little bit, that's going to help me. And maybe if I can give you more early strength, that'll help you get the saw cut on a little bit earlier, these kind of things. So even my focus of what I necessarily QC to or kind of like follow and track at the cement plant, I'm even looking at it a little bit differently. Don't get me wrong, I'm still concerned about 28-day strengths and I want you to make your strengths, but some of these other field conditions or things that are happening that maybe I can affect cement wise, we're looking at doing those kind of things, tweaking it on our end. Okay. So that's what I mean about maybe redesigning our mix just a little bit. Yeah. You know what? That is a bang on point. And I will never disagree with you on that point because it absolutely is. We all know that things like fly ash, slag, these SCMs, great long-term durability, right? I'll never tell you not to use an SCM. I'm a big fan. Okay. Sold a lot of them in my career and I've know the benefits. Okay. But they're also natural retarders. So in the summertime, you think, oh, we want to retard, but now I'm telling you, maybe we don't want to retard as much as we used to want to retard because when we retard it, we are more after plastic shrinkage. It's like this dichotomy, right? Can't have my cake and eat it too. And we also know that fly ash, slags, these kind of SCMs traditionally are byproducts from a different industry, which means that their CO2 footprint is much lower than the CO2 footprint of our cement. Okay. It's another way the sustainable green aspect of them is really good. So yeah, taking out SCMs, yes, helps my set time, but now I'm taking out this low CO2 footprint material that's in my concrete, and now my global warming potential of my concrete isn't as good as it used to be. And absolutely, is it like this battle of two sides? It is. And I don't think we in our industry, we understand that and we see it. I don't think that's being understood or cared about. Maybe, what would I say, above the people on the field in the industry. Does that make sense? But absolutely, I give you a low CO2 footprint cement, but I tell you you need an extra 100 pounds to make your concrete the same. No, right? It doesn't make sense. I agree. It's a very fair point. Very logical, point too as well. A lot of people don't grasp. So very well put. The use of evaporation retarders and finishing aids. Anybody use these in the field? Evaporation. Do you have any success stories or dislikes or anything you'd like to share? Saws earlier. Yeah, I've heard that too, that getting on with the saw sometimes is not as quick as it used to be, right? You want to get on it quicker and then it still ravels and then you've missed your window all of a sudden. I will agree this finishing window from what it traditionally used to be, and I don't have a finishing window graph up here, but finishing window from what it used to be has shifted, right? It's shifted a little this direction, and some of those, my saw cut window used to be like this, and now my saw cut window's like this, right? So it has adjusted, and we as an industry need to adjust with that or try and compensate for that adjustment. A couple things I will tell you, that evaporation retarders and finishing aids are not the same thing, okay? They're used for different purposes, and evaporation retarders should not be finished into the surface, okay? Although finishing aids have some water in them, evaporation retarders are like 9-part water, okay? So if you finish those into the surface, you're going to struggle, and what you're going to do is just create a weakened plate at the surface, right? We're finishing more water into the surface. So that's the only thing. Know when they should be used. And I was, depending on the finishing aid, I've been learning so much here the last month about some of this stuff. Depending on the finishing aid, when you can and cannot put it down is a huge thing, right? I thought you could use a finishing aid like throughout the whole process, like straight up. I can use it before I bull float, right? I put it on and it'll help me bull float and close up the surface. Not all finishing aids are created that way. So some of them are only truly for final finish, after bleed and after when I do my final finish. So just know that if you're going to use those kind of products, I think they're great. Just know that those come with their own sets and bounds, and make sure that you know what they are, okay? And there's some of these products, finishing aid helpers, that are also integral in your concrete, right? That are nano silica that go in your concrete, that you take it out of the finisher's hand, you take it out of the contractor's hand, you put it in your concrete, it's delivered in your concrete, and it's supposed to help. Okay, so know that I'm never going to tell you a product to use. That's not my job. I just want to give you the information about, hey, that kind of stuff is out there. So if you're struggling with this issue, here's where you should turn. Here's what you should look for. Okay. Who asked me that question? Ha. No, but it's turning out to be one. So I talk a little bit about VMAs here in a little bit, but it's a good question. Who knows what a VMA is? Okay, a viscosity modifying admix. Who knows what we used to use VMAs for? Pretty much only time we saw them. What do we use them for? Self-consolidating concrete, right? You might have had it at the ready mix plant, but you only used it for SCCs. Okay. And what a VMA does, for those of you, we all know what water reducers do, right? Water reducers are put in our concrete to give us slump. Okay. So positive and negative charges within our concrete. I'm going to get a little nerdy on you, chemistry wise. Positive and negative charges in our concrete, we want to repel. Okay. We do that by using a water reducer, repels the positive charges from each other. Okay. It's like opposite ends of a magnet. Okay. That's how water reducers really work. Dumbed down version. Okay. A VMA doesn't work that way. A VMA does not give us slump. It gives us cohesion. Okay. And when I say that, the reason we use it for SCMs or for SCCs, we want a 20, 25, 30-inch flow. Okay. When you put more water in a mix, who's been on a job, when you put more water in a mix and you wet it up from a 4 to an 8 and you pour it out, what happens in front of the coarse aggregate? that comes out? Have you ever seen that halo? Like this water halo? What's happening? Our products are separating, they're segregating, okay? The water's coming out, the paste is coming out from the coarse aggregate. We want it all to stay as one cohesive bunch, okay? Excuse me. So that's what happens when we wet it up. In order to keep that from happening, keep it cohesive together, we add a viscosity modifying admix, okay? It basically keeps that water in the mix, okay? Keeps that halo effect or that segregation from happening. So we have found that with the concrete today made with Portland limestone cement, adding these modifying admixtures give us some workability, okay? They seem to allow us to, it frees up that water, excuse me, that frees up that water to come to the top and gives us the ability to close off that surface. I don't know how many comments I've heard, and it's one of my slides, but we'll talk about it now. How many comments I've heard that says, hey, I can't get it to bull float, right? It used to take me 5 passes. Now it takes me 15 passes or whatever to get my surface to close up just initially after I've screeded it off. I said, well, shoot, that shouldn't be the case. So we found that VMA helps that initial close up process and actually frees up some water for you long term. And guys that use it in their concrete say, I see water. I see bleed water on the top. It gives me a sheen. It reduces my plastic shrinkage because I've got this free water now coming to the top. So to your question, would I call it a finishing aid? No. But does it have benefits of giving us these kind of things that we're lacking in a mix? Yes. Okay. Now, with everything I'm proposing here today, I understand that there's cost associated, right? Nothing is free. And there's a downside too. VMAs can retard, okay? Depending on the dosage of your viscosity modifying admix and what brand it is or whoever makes it, it has retardation effects, okay? So if we get into those higher dosage rates, that's the only caution I would tell a ready mix producer or even a contractor in the field that orders concrete with a VMA in it. I say, give it a try, see what you think, find the dosage rate that works best for you, but be cautious because higher dosage rates retard. And what happens when we retard? We get spongy concrete, okay? And now we're back in this situation where I've got a hard surface and smooshy underneath, okay? So just know that there is pros and cons, but I think the pros in a lot of situations outweigh the cons as long as we use it properly, okay? Does that answer your question? Okay. Anybody poured any concrete with VMA in it? Do you guys use it? Yeah. Yeah. Uh-huh. Yep. I've got away. So that's, I mean, that's a good story. And I think once again, using a product that we weren't traditionally used for that application, but we're finding it works. Anybody pour microfibers? That's one I didn't talk about on here. Yeah. Okay. So microfibers, good situation for this plastic shrinkage. Okay. Because we know microfibers, they're so tiny, they're in that mix every which way, all crisscrossy, and it helps hold that concrete together when it hasn't built up the strength to keep that tension. Okay. It helps hold those cracks together. So think about that too. Microfibers are really great for plastic shrinkage. And some people will tell you that microfibers also help usher bleed water to the surface. I don't know how to prove it, but anecdotally, I kind of understand it. But it's supposed to provide all these opening pathways for bleed water to come to the surface if we have too much like particle packing, which we'll talk about here in a little bit. But so microfibers are also another one of those things that helps with this plastic shrinkage issue. Okay. And I have to pour this, I have to put this one in there. Prepare the subgrade is my last one. It is more important than ever to have wetted, that was not a word, a wet subgrade, okay? Or a wet base that you're pouring it on, okay? Especially when we're using limestone crusher fines, okay? That soak up the water like crazy. We need them to be wet. And I know this sounds silly and me telling you kind of basic things, but these basic things can sometimes make a world of difference. Who likes to pour on plastic? Who has like love-hate relationships with pouring on plastic, right? I mean, like, so who only pours on plastic when you absolutely have to? Yeah. So there will be people out there that'll tell you today, and I'm in the category of, oh, I have more bad about plastic than I have good, but people will tell you today that pouring on plastic actually helps us with PLC. Why is that? Because there's no water that can go down, right? All of that bleed water that is inherent in your concrete, none of it can go down. It all has to come to the surface. Okay. The flip side of that is it takes a long time for the bleed water at the very bottom of a 5-inch slab to get to the surface. Okay. So now we got to wait on it. What happens when we wait on it? We open ourselves to plastic shrinkage cracks. So I wish I had this bulletproof, like, recipe to throw at you that says do this, 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 and this, and you'll never have a problem. Foolproof. I like foolproof things. I can't deliver it to you. Okay. When we all know that you might have had more foolproof recipe when you were using a type 1-2, we don't have a foolproof recipe, at least as bulletproof as we used to. And I'm sorry about that, but it is what it is. So we're just trying to come up with some different ideas on how to give you some safety and some cushion. Okay. But also this bottom corner, if you're out to a job site and you're bringing concrete, don't pour on that. Or if you pour on it, record yourself saying, I'm not coming back to this job when you call me about it cracking, because it's going to crack in all those grooves and holes and all that wetness. So just do yourself a favor. And when you see situations like that, like always, document it. Okay, question number 3. What time is it? We're doing good. Anyway, we're just an hour in. Everybody okay? Don't need a break. We've got lots of time, so I don't want to like wear you out with me droning on and on. So if you need a break, just tell me. Why is there no bleed water? Who feels that? They're out to a job or have had a contractor say, I don't have any bleed water. I have broken the bleed water theory down into what I call 4 buckets. Okay. You'll have lots of people think different things. First bucket, the fineness of our product has changed. And I have kind of 2 examples of mill test reports over there on the side. Who's ever seen a mill test report? Hopefully you ready mix guys at least are familiar with those, okay? But mill test reports are kind of where we list what's going on chemically wise, physically wise with our cement. But our mill test reports tell you that our blane has changed, which is basically the fineness of our product, okay? Who is familiar with type 3 cement? Yeah, what do we use type 3 cement for? Pavement patching, road patching, stuff that we need to accelerate, stuff that we need to get on and off of real quick. Okay. The base chemistry for a type 3 cement is exactly the same as the base chemistry for the Portland limestone cement. We use the same clinker. Okay. We grind it finer to make it more reactive, because when we expose surface area of our cement, that's what makes it more reactive. The more surface area, the quicker it reacts. Okay. But the more surface area we have, the more water it takes. Okay. So there's no doubt, we already talked about it a little bit, that we're grinding this limestone and this clinker together now, and the fineness has increased in our product because the limestone's easier to grind. Okay. So we've gone from what are these examples on here? A 361 is what my type 1-2 used to be. And now my PLC is at a 426. Okay. So we've absolutely gotten finer. Could that be a cause why we're not seeing as much bleed water? Absolutely, because the water demand of our product has gone up. And I will tell you that I run concrete week in, week out, 564 pounds of cement at a 4:5 water cement ratio. I track the air, slump, set times, and strengths. Okay. Apples to apples, bare bones comparison. And I'll tell you that my slump has gone down. Okay. I'm not getting a 3.5 or 4-inch slump anymore at a 4:5 water cement ratio. I'm getting a 2. Okay. So there, I tell you, my water demand has changed because my particle size has changed. My fines have changed. Okay, so that's one bucket why we don't have any bleed water. Another bucket is with the increased fines, we have increased particle packing, which is absolutely true. Why do we like silica fume? Silica fume, a pozlon, it reacts, right, with calcium hydroxide, performs more CSH, but we also like silica fume because it's so tiny, okay? Where do we use silica fume in KDOT? Bridge decks, right? Because we need that permeability number, right? We need that low permeability number. Silica fume helps us densify things. Theories out there say maybe we've got too much particle packing now. We're so packed with these extra fines, these limestone fines, that we don't have enough pathways for our moisture to get to the, for our bleed water to get to the surface. Okay, so that's absolutely a theory, and in reality, we like that particle packing, right? It gives us better strengths and these kind of things, long-term durability. But have we gotten to the point where we're too packed and we don't get the bleed water to the top? Maybe. How do we prove it? I don't know. Who wants to go back to gap graded mixes? I don't know. See if we get more bleed water. I don't know. But I will say that tweaking your aggregate percentages, upping your coarse aggregate, lowering your fines a little bit, have proven to work for some people when it comes to bleed water. Okay. We all know that tweaking those kind of things work when it comes to pumping and finishability and these kind of things. So continue to tweak those mixes and specifically focusing on bleed water. So that's another theory. Another one, we talked a little bit about it already. Jerry brought up the question. Limestone quality. The absorption of the limestone. Is it important on the micro level that we grind these particles to? I don't know. Could it be? Because I know absorption is highly important when we talk about concrete mixtures and water demand and adjusting your moistures and those kind of things for concrete. Could it be? I think it's a possibility that needs to be looked into. Do we need to evaluate this? Absolutely. I don't have the answer to answer that question, but it's another one. And the another one is, I had a contractor tell me once, he's like, I don't know what you're complaining about bleed water. It's still there. You just got to wait on it. I said, love that. Well, you want to tell everybody that for me? Because they don't want to hear that from me. Because what happens when we wait on it? Our surface dries out and we get plastic shrinkage. Okay. And we can't finish it. So, so all of these pros and cons once again, but those are the 4 buckets of why I don't have bleed water. What to do about it? We got to think outside the box. Yeah. Mm-hmm.
Bleed water.
The bleed water that does not come out look like in a petrographic analysis. Everybody know what petrography is? It's where we take a cylinder or a core, just let me explain, where we take a cylinder or a core and we look at it under a microscope and we can evaluate what's going on in that concrete. We can tell you what the percentage of coarse aggregate is, what the percentage of fine aggregate is, how much cement's in there, how much fly ash is in there, if we've retempered the mix, what the rough water cement ratio is, these kind of things. So back to your question, what does bleed water look like when it has not come out of the mix? I think you would see it you'd first see it on a surface issue, okay? And so you'd see like some sort of surface issue, delamination, blister, something like that, where we've densified the surface and not allowed that bleed water to come to the top, and it gets trapped there underneath and causes delam or causes a blister. If we take a core of that section and I ask them to evaluate the water cement ratio at the top versus the water cement ratio at the middle versus the water cement ratio at the bottom, the petrography will tell me that the water cement ratio at the top is far higher than the middle and the bottom section. Does that make sense? And that's kind of where I would say we've either trapped in the bleed water or we've added extra water to the surface. Could I tell you exactly which mechanism is happening through the petrography? I don't think so. Or I've never read a report that would tell me the exact mechanism, but I'll tell you that there's more water at the surface for whatever reason. Does that answer your question? You mean in air?
There would be
Yep.
it'd be
I have never had a petrography that came back that way. Has any of you other guys that look at petrographies on a regular basis ever experienced a hardened air void analysis that tells you I have elongated bubbles that indicate water versus air? Yeah.
By the time you get around to looking at it, in Microsoft, all those are just standard. So you could identify or where the water was, but I don't know that you can tell exactly when.
Yeah.
I
we had some come back.
Yeah. Yeah. Explain. Yeah. Uh-huh.
And they
And they visually saw large elongated bubbles that had then since evaporated, and they said that was trapped water.
correct just under the surface. Like, down.
I think it was
All through the mix.
yeah.
Hmm.
I'd have to
Yeah.
had something to do.
If you've got trapped water in there like that, I'd almost think that I'd see more consolidation issue there, right? That doesn't give us a chance to come to the surface. But yeah, yeah, laser screed. That's interesting. I'd be curious to see if they saw it all the way through the core, and if they did, my opinion of what it is might change. If it was at the very surface, I could absolutely see the mechanism that you're talking about. That if we had these weird shaped, larger sized bubbles that didn't show as a normal bubble for air, yeah, absolutely could be bleed water trapped on the surface. And I think they'd be able to tell you that too about just the densification of the surface of that concrete. Did you core it because it delaminated?
Yeah.
Okay. So,
There were some
right.
there were
That had some, okay, that you compared like a delaminated core to a non-delaminated one kind of situation. Yeah. So I would think that densified surface is already gone, right? And so that's very possible. I'd be interested if there was bubbles below that top, we'll call it eighth inch or whatever, right? Whatever they millimeters, because they always talk in millimeters in their reports, but below that top surface, if there was those bubbles, them getting trapped down there, I think might be a different mechanism, but it was on the surface. Absolutely. That bleed water got trapped in by densifying the surface, sometimes with steel trowel, sometimes with Fresnos, sometimes with these kind of things that you shouldn't use, or just overworking the surface in general before it's ready. So good question though. That made my brain work. Thank you. Any other comments specifically? I think petrography is a good question. Any of you looked at a lot of petrography reports of stuff here recently? Yeah. Um, Bobby, do you have any inputs on that kind of stuff? Yeah. Yeah. Yeah, and it reads as a bubble under the microscope. Yeah, the void. Yeah. Okay, good. Yeah, you guys do that in house, don't you? I send all my stuff to a lab. So, yeah, they do that in house. Okay. Good question. But bleed water, back to bleed water, thinking outside the box. We've kind of mentioned some of these things. We talked a little bit about VMAs and how they seem to not only help with this finishability thing, but they also seem to give you this sheen on the surface that pushes the bleed water to the top and helps the bleed water situation. So I've had that feedback. So I think that's a good one to try. Um, I know that at cement plants, we're continually trying to like, if I can tweak my blade down a little bit, will that give them more bleed water? Will that give them less water demand? Like, so we continually try to tweak those things on the cement side as well. So we're trying to give you your bleed water back, I guess is what I'm saying. We talked a little bit about plastic. I've had some guys that say, oh, I like to pour in plastic now because all the bleed water comes to the top. Pluses and minuses, but thinking outside the box. And I always like to put this slide up. I don't know. I don't sit in my wheelbarrow like that, but it's pretty cool. Rest and wait. Although resting and waiting is not your only solution, because, like I said, that brings other nasties to the table sometimes. So resting and waiting is not always the solution. But if it's there, let it come to the surface. Let it come up, and do your best to protect that surface from evaporation. Too much, then you'll have that bleed water. Question number 4. At this rate, you guys are going to get out of here way early. I didn't prepare enough information, I guess. That's the way I like it. We have lots of time for discussion. Why can't I get the surface of my concrete to close up? So we talked a little bit about that. So I have lots of guys that say, I'm not even talking final finish. I'm not talking power trowel, rock behind trowel. I'm talking after I've screeded it off, after I've done the latest screed, vibrating screed, whatever, and I go over with the bull float, I can't get it to close up. It takes me lots of passes, more than I used to. And guess what happens when I have to put more passes on it with the bull float? I end up overworking it. Or we're tempted to reach for something else, like water bottle, as my earring just fell out. It was awkward. We're tempted to reach for a water bottle or something to spritz the surface, right, and help you work that closed. And we often give finishers a bad rap for like blessing it after the fact when we're putting the final finish on it, but blessing it beforehand to get the bull float on it is just as detrimental, right? We're increasing the water cement ratio at that very surface and can cause surface issues. Okay. So why can't I get it to close up? Don't have an answer there. We talked a little bit about bleeding, and we talked about particle packing, and all these different kinds of things. They all play into why we're having trouble finishing it. But I'll tell you what, something that's really piqued my interest here recently is what we call a float test. Anybody heard of the float test before? Dr. Tyler Lay out of Oklahoma State University really touts this float test that they do in their lab. And basically it's kind of a rudimentary test. And I know it's not a 3x3 square is not a real world huge slab, but we're always looking for things that we can do in the lab on a small scale to learn, okay? To learn what kind of changes we can make that help influence things in the field. Okay. And the float test is one of those things that we're going to start implementing. I've actually started to build a couple of them for my lab in Kansas City. So basically what it is we build this box and we put concrete in it. Okay. And we have a cut down bull float, and it's on this yoke in the back of our box. So we're always at the same angle, and we just push it across the surface, back and forth, back and forth. And basically we do 2 things. We count the number of passes that we're making. And we've also made these holes in the middle of our concrete, these 1-inch diameter holes. And we count how many passes it takes to close up those holes. And then we count how many passes it takes to get to the surface finish that we want. And he's got a graph. It's 1, 2, 3, 4. Okay. A 4 might be for the stuff that you need super level, super high grade finish. A 1 is, let's call it the apron for your feedlot, that you don't care about really what the surface looks like. Okay. That's 1 to 4, but we decide what kind of finish we want to go to, and we count how many passes that takes. Tyler will tell you he's done some research in his lab that says not all cements are created equal on this. Some PLCs perform better or worse than their 1-2 counterpart, and some cements perform better or worse than their competitor cements. Okay. He doesn't tell you who is who, but he'll tell you that he's seen that not everybody's performance is created equal. Some of it related to PSD and how the PSD, the particle size distribution of your cement, looks. And a lot of it also related to mix design. Okay. So this test is a really good one, and why we're going to implement it at my lab. And I think there's some ready mix guys that have been looking at it too, that says, how can I change my concrete to make it better for these guys in the field without them having to call and tell me this was awful, don't try this again, try something different, right? How can we do something in the lab to get kind of the right direction? Whether that's changing our coarse to fine aggregate ratio, whether that's changing cement content, whether that's putting in more or less SCM, whether that's using a VMA, how the dosage of the VMA is, whether I make changes at my cement plant, I change my fineness. Does that change how it performs in this test? I change my limestone percentage. How does that perform in this test? These kind of things. We're really good at testing cement. We're fantastic at it. Okay. But we're not so great at testing field things besides strength. So this test, I think, is going to become more and more prevalent as we continue to troubleshoot and work through what works with these new mixes. Okay. I think it's a really good test, pretty easy to do, not super complicated or technical. And you can run a bunch of variations to see what helps. Okay. So go ahead. Yeah.
So that's nice. I see it.
Right. We don't have any of those other conditions. You're absolutely right. And that might be a factor too. Maybe we try one that sits on a dry limestone, or we try one that sits on a piece of plastic and see how much that affects this test. And a bleed. And help me, cement guys. There is a bleed water test, right?
Yes.
Okay. How many of you do it? You've started doing it. Okay. So you guys know. No. So we haven't started doing it, but I will tell you this. We do set times all the time. And in the ASTM test method for set times, if you have too much water on the surface of your sample for your set time, you're supposed to suck it off, essentially, and so you don't have pooled surface on the top when you run your penetrometer. I don't ever have to suck bleed water off the surface anymore when I run a set time. Okay. So that tells me that my bleed water has changed. And I think that the bleed water test that we typically haven't run for a really long time is also going to become more prevalent in the cement world as well, as we continue to work and troubleshoot these issues from our angle too. Okay. Been a long time since I've ran it. So
Certain examples, big bucket.
right.
And when you suck the water off, then you measure water's coming in, and you do that lot of how much water's come out over time.
Yeah, and at certain time intervals, that's the important part.
Unfortunately, it's mixed specific.
Right.
It's not something we look at it with. That's just gonna be different for whatever
Yeah.
we see, and we can kind of track trend.
And,
Really.
yeah, and I think that's a good suggestion for your base mix every week. Tracking the trend tells us a lot, whether it's specific to your mix at MCM. No, but it tells us what the trend is. Now, do you sieve out the coarse aggregate? Okay, so that yeah, yeah, so that's good. Sieving out the coarse aggregate? No. Yeah, you're dealing with the mix. What the mix is, yeah, but not the set, like not a specific gradation. Right. And so I think that's why you could use it as a tool. Say, hey, I want to go from, sounds silly, but 60% coarse aggregate. Well, okay, here in Topeka, are we still like limestone based and sand based, or have we hit the mark in Kansas where we're now this like weird sand and gravel that's higher? Remind me of what's going on right here local, because I know we go to Western Kansas, lots of sand and gravel, high sand and gravel mixes, not so because we don't have a lot of coarse aggregate. Kansas City is the other side of the spectrum, lots of good coarse aggregate, and the sand. Or Topeka, are we somewhere in the middle here? 50-50. Okay. I look at mixed designs from lots of places and I don't always commit them to the memory. So, but 50-50. Okay. So, depends. Yeah. And depends on what you own. And right. Makes logical sense, right? It's all about dollars and cents, right? So, but in those kind of instances, a test like this will help you evaluate whether 2%, 5% makes a difference when it comes to this kind of like finishability. Because I didn't realize when people would tell me about finishability things, this closing it up at the float stage is a real issue. And if they can get past this, they can still work past the final finish, right? They've got tools on the final finish age, but if we can figure out how to solve this issue at the beginning for their preliminary finish with the bull float, that really helps. So so we're focusing on this test and looking at some different ones. And I'm glad Joe mentioned that. I think we should start looking at bleed water on a regular basis now to actually measuring it per the ASTM test method. Because when I would pull bleed water off the set times, you sieve out the coarse fraction for a concrete set time in the lab. You sieve out the coarse fraction just like you would for a set time in the field. If you had a pocket penetrometer, you'd sieve out the coarse fraction and do it in the field. But that changes your bleed. Absolutely, it changes your bleed when we take out all the coarse aggregate. So, but just some things that are going on. And once again, we've talked about those outside the box, the VMAs, the trying to adjust our aggregate ratios, maybe some microfibers help with this, closing up of the surface. But yeah. Good question. When he presented it to me the very first time, after we talked about it, and he showed me some graphs and we talked about in the one cement he tested, the PLC absolutely had more passes to get it close to the same place as the 1-2. And then he talks about the particle size distribution and whether you have a nice curve or whether you've got a couple peaks and valleys, these kind of things. He intends to try and relate that to PSD and how the PSD of cement is changed now and how that affects us truly in the field is kind of how he relates things. And he actually approached me. He's like, hey, there's this really high dollar PSD machine out there that not only tells you the PSD, but it also can tell you exactly what each one of those particles is. So it can tell you whether that is a limestone or whether that is a cement particle. It's like the highest grade PSD machine out there. And he tried to hit me up, like, if you buy it, I'll run all the tests you want and have it at my lab. And I said, Tyler, if I had the money in my budget to buy it, I absolutely would. But I think that's where he's going. He's trying to help our industry, especially from the cement side, understand how our particle size distribution has changed with the new Portland limestone cement and how that relates to things that we see in the field. He has shown data, excuse me, specifically, I picked up a cold last week and I'm trying to get over it. Specifically, one cement that he shows data in his presentation, he talks about the marked difference between the type 1-2 performance and the PLC performance. And he highlights that data, I think, more as a point that says, hey, look, we can learn something from this. Now, if you talk to him offline, he will also tell you that he's tested other cements and the type 1-2 and the PLC perform very similarly from the same plant. But he will also tell you that plant to plant, different, right? So my PLC might perform differently than Joe's or than Bobby's. And then like we all perform a little bit differently, not good or bad, but different, right? And if you are armed with that information up front, then prepare for it in the field. That makes sense? So, and I use it more as a tool. Like if I'm the one that performs the worst, I use it as a tool to go back to my plant and say, hey, I know we're not doing well in this department. Let's try to change one thing and see if we can do better, right? And so I don't necessarily use it as a negative thing, but I use it as a tool to continue to get better. So that's how my implementation in my lab is going to go. When I brought this up and said, hey, I'm going to start building these things that are very cost effective, right? It's just 2x4s and some screws. But when I said we're going to start doing this test, the plant's like, well, how are we supposed to meet it? Well, I said, I'm not holding this as a stick to beat you with. I'm using this as a tool to learn from so we can continue to improve, right? So Well, the data he shows you when he does a presentation on this, or if you go to his YouTube, if you guys don't follow Tyler Lay on YouTube, there's so much concrete social media stuff out there that some of it I would tell you to stay away from, but don't stay away from Tyler, right? He teaches you concrete really well. He's got a YouTube channel that's super engaging and fun and a list of huge topics. So Dr. Tyler Lay on YouTube, he calls himself a concrete freak, and he gets me excited about concrete, and I'm a concrete nerd already. So like he does a great job, but in his video, it's like a 9 or 10 minute video talking about this test specifically. Yes, his example is a cement comparison. And then he does a microfiber or a microfiber dosage comparison as well, because he's like, hey, everybody tells me that they can't close up the surface with microfibers. And then he shows you about how many passes it takes at, a quarter a pound, half a pound of these kind of different things. So those were his two comparisons that he does in his video. But like I said, utilize it for whatever thing you want to compare. Aggregate ratios, cements, but anyway, another thing that we traditionally haven't done in the past outside the box that has kind of come to the forefront as PLC is, our cement, and it's prevalent and it's here to stay. Things that we're trying to do that are different to continue to grow and learn and do better. Okay. Uh-huh. Right. If I say, hey, in the lab, in a controlled 70-degree environment where, here is what my baseline is. And if I use it as a comparison mode specifically for myself and know that week in and week out, either it's consistent or it's all over the place or whatever, that teaches me something about my cement consistency or my concrete consistency, right? If best case scenario in the lab always, right? We don't have all of these outside influences. So if I'm going to say this, and this is going to sound awful. If I can't get it to work in the lab, no way in hell you're getting it to work in the field. Pardon my language, right? So that's why I do like to do things in the lab, is because I can get it there. It's a controlled environment. And then we know that we've taken all of that out of the equation. And all now we have to do with is the environmental conditions. That makes sense. So I could traditionally go to a ready mix guy and say, hey, these are the tweaks I've made in my cement. It shows that I have a performance improvement in the week in, week out concrete that I do. Let's do it with your mix. Let's do it with your aggregates. Let's do it with a couple of your mix designs and see if we see improvement. These kind of things. That's how I see this test being utilized.
Well, and I think you brought up one of the benefit, and this would bear it out if you just did this simple test at your plant and then spend a couple ounces of PMA.
Yeah.
And look to see if it did anything different.
Yeah.
Was it
Yeah.
easier to close it?
Yeah, exactly.
Well, better across it, see if one.
Right. You can absolutely, do those kind of things. Yeah, that's a good thing even for the lab. I'm glad you mentioned that, Chaz. Like, put a fan on it, or I'm building mine on rolly carts because in the lab we're all about ergonomics, right? I don't want to have guys to bend over, so we're building it on a rolly cart. Hey, let's roll it outside and do it outside instead of in the lab. Expose it to a condition like that. These kind of things. Uh-huh. Right. Right. Yeah. Yeah. You could. And I think as this continues to evolve, I think we could get that technical that says, and I think that'll help us answer those questions too. Is that evaporation rate number right? I don't know. Maybe we learn something from this. I finish at an evaporation rate number of this, and the next day I know my evaporation number is that. I'm going to do the same mix, and I'm going to see what it looks like, right? Problem is, I have all these great ideas running around in my mind. It all takes time, right? And I can't answer it for you today. All I can say is these are the things that are happening in our industry, and as we continue to build up this knowledge and this information, my goal is to continue to share it with the masses, right? And say, here's what I've learned. Here's how we are all doing better. But absolutely, we could take it that far for sure and give you this kind of window and figure out where our window has changed, And I'll tell you that my finishing window, my finishing window. That doesn't make sense. The finishing window for concrete made with my cement is probably different than the finishing window for concrete made with Joe cement or made with Bobby cement, right? Because although cement, we all manufacture cement the same way roughly, we're not all the same, right? I'll tell you that I don't want to be awful. Like, I don't want them to have way better strength than I've got. And I don't want them to have way better characteristics than I've got, so I can change things. But like, if I hear from the field, be like, oh, you're really underperforming. Okay, well, thanks for the feedback. Let me try and change something. But we're all just a little bit different, and we're always going to be. But that was no different when we were with Type 1 too. We all created a little bit different product. Okay. So
Good talk. This is somewhere we're seeing some really research coming from colleges and stuff. Tyler Lake does all kinds of stuff. I'm really interested in what Jason Weiss is figuring out as far as the actual characteristics of the bleed. That was something that he brought up at one of the recent ACI conventions. And it's just all stuff that we're starting to figure out we need to look at now that we've made the switch.
Right.
There's tens of thousands of studies and papers and everything leading up to us switching to TLC that show we can have the same strength, we can have the same set time, we can have the same sulfate resistance, we can have the same ASR. That's why it came out the way it did.
Yeah.
As far as it's similar, but it's these kind of things.
Yeah. And I think to Joe's point, I was like, well, why didn't you do your research before you rolled this out? Why didn't you know this was going to happen? Like, okay, gentlemen, we did our research before we rolled this out. We're not the first ones to use PLC. Europe's been using PLC at higher replacement rates than we have for a long time, right? Canada has been using it as their primary cement since, like, I don't know, 2010, 2012, something like that, somewhere around there. Okay. So it's not like it hasn't been used, not like we didn't research it. I could put 5 years of data up there and change all of the dots to the same color. And I would tell you that 2 years of Type 1-2 production and then 3 years of PLC production, I changed all those dots to the same color. You couldn't tell where we made the switch, strength-wise, set time-wise, because that's how we wanted to do it, right? We made changes at our plants to make that happen. But once again, it's in the lab, right? Controlled mix, controlled setting, and these field issues that now are really rearing their ugly head. I don't know how we predicted those. I don't know how we could have predicted those. So I'll own that. I wish I would have figured out how to predict those, right? But from what I was looking at and what I was testing when we rolled it out, I truly thought, hey, we're not going to have too many struggles. Okay, we're going to make some changes to water demand, maybe tweak some changes to air. These surface issues, they were tough. They're tough to predict.
I would also add that the slide that she threw up there for shrinkage cracks is no different than the one we've been using for the last
right
50 years. It's the same concept.
Right.
It's just now it's different.
Right. Evaporation rates have not, how we calculate them, how we're supposed to look at them, has not changed.
What all us is the actual
right.
Has not changed.
Has not changed. The mechanism has not changed. All that has gone away is your ability to get away with not doing those things. You used to be able to get away with not doing those things. And I'll tell you what, I always have somebody in the room that says, I do it all right, and I still have problems. And I don't doubt that person. None of us go out to do a bad job, right? We all want to, like at the beginning of the day, we want to go out and have a successful, good day and end our day with success. So when somebody comes to me and say, hey, I do all these things right, and I still have some jobs that happen. And I feel like that used to happen to me with Type 1-2, but maybe I have those a little bit more often. And I'll say, yeah. And that's why concrete is an art and it's a science. And some days those two do not line up, no matter what you do right. And do you have more of those days than you used to when you do absolutely do everything right to protect yourself and still have issues? Yeah. And that's why I think we just have to know that things are less forgiving than they used to be. So it's even more important that we do all the things right to increase our chances. I see lunch is getting set up outside. Do we want to take a break before lunch? I have one question left, but it is by far the most heated one. So question to the group. Do we want to talk about it, or do we want to break for a little while, have some lunch, and then finish our day with the most heated, probably most conversation we'll have on a topic? I think we take a break. Is everybody okay with that? Okay, let's take a break, get some lunch, and we'll start back up and end the presentation with the question that I get most often, or the things that it's about a quarter after, guys. Why don't we get started here in the next 5 minutes? How's that sound? So it's your last chance to bail. Yeah, Audi. It's like church. You came for communion and now you're going to leave, or you came for lunch, now you're going to leave.
I'll go see the answer that I thought I could do it. They said that from most school. Yeah. And I haven't thought like this. It's crazy. Here.
So is there a standard like from the
An ASTM
an AS
standard, and I don't know the number, but I can find that out and let you know.
Oh, it's not a big deal. I'm
Yeah.
just curious. I'm just thinking, well, if we have a baseline of what it used to be in comparison to what it should be.
No, that's the problem. I don't have any old cement samples. But that's a good point, and I should look for some.
Yeah.
And see if I can find some.
I was just thinking about that.
But no, I haven't run it in ever, I don't think. Maybe once, you know.
I don't know if there was a chart on the ASTM standard.
Yeah, I don't know.
Like that.
I'd have to look through the method and see.
I always envision this. Okay, I got this test I'm doing, but I don't have anything. I don't know if it's good or bad.
Yeah, it's all about
This was
mils of
salt.
water, whether it's more or less. Yeah. No, I'd have to look. There might be some research out there. I'd have to look though, dig into it. Yeah, should. And I think it's something we should utilize more. Sounds like Joe's starting to do it, so I think it's a good thing.
I think it's key with all the timing issues that the guys are having.
Yeah.
And it doesn't bleed, but then they get on it and they work the hell out of it, and then they end up with dehydration because they overwork the surface.
Right,
What were you working?
right,
There had to
exactly.
be some cream
There had to be
water
something there. Right, exactly. I agree.
Wouldn't do anything.
I agree. All right, everybody. Try and get started here and then get you out of here a little early. Then maybe you don't have to go back to work. You just, I don't know, you go home maybe, give you some downtime. I don't know. Yeah. Thank God I listened to this really long-winded woman all afternoon. She just wouldn't shut up. Typical. Yeah, I know. Till 6 o'clock, right? And we need to have beer in if it gets past that 5 o'clock hour. Gone is the sweet tea. Okay, so let's pick up with my most often asked question that I feel like I've been getting inundated with for sure for the last springtime since the winter ended. Biggest question: why is there so much concrete out there experiencing surface issues? Okay, who has felt this? Who has seen this? Who has felt like there's an uptick in this all of a sudden? Yes. Okay. So when I talk about surface issues, there's different mechanisms out there. All of them have some things in common, which are what we're going to talk about here next. But I want to make sure we understand each one of these as they are different functions of what's happening. Okay. So the first group of 3 pictures, it's hard to. Anybody want to tell me what this is? Just traditional scaling. Okay. Often we relate it to salt scaling, freeze thaw, different kinds of things, mechanisms for scaling that are really specific to scaling. Definitely ingress of salt from de-icing chemicals, and then obviously we finish water into the surface and create a weakened plane, and then freeze thaw. Just the freeze thaw cycles affect scaling as well. So those are the main mechanisms there. The 2 pictures in the middle, both a little bit different, but caused by the same thing. Anybody know what those are? Blisters and delaminations. That's, oh shoot, that's not what my animation says. We go to the top corner, just joking. Pop outs. We all know what those are. Those are super easy to see, conical in shape, usually over a coarse aggregate because of some chert or shale or impurities, and the surface comes off right over the coarse aggregate, conical in shape. Pop outs and scalings do not pop out in scaling. They do not look like each other. Okay, they're definitely 2 different mechanisms. Go to the middle. We just did that one. Delaminations and blistering. We talked a little bit about that earlier. The main mechanism is there. Yes, absolutely. There's commonalities, like I said, but once again, we're densifying the surface by overworking it, and we're trapping in the bleed water, or we're trapping in excess water. And that surface is very dense, and it creates this weakened plane and just causes these blisters or these delaminations to happen. Okay. Oftentimes people use the term delaminations and scaling interchangeably. And I catch myself doing it as well, but they are different and they have different mechanisms, but they kind of look, especially when your delaminations are more than just a few blisters. When your delamination spots get big, they can look like some severe scaling. Okay, but the mechanism there is just a little different. Okay, and the one in the bottom corner, anybody want to take a guess at that one? Any guesses? Spalling. Okay, we often use this term interchangeably too, and that's not the case. We'll typically see spalling around joints and over rebar, and spalling absolutely a lot of times when we see it in the most severe cases is a function of some chemical interaction with your rebar. Okay, so scaling and spalling are definitely not the same thing. what happens on your driveway is what I would classify either as scaling or delamination. I don't see many driveways that spall in the traditional sense. Okay. So just when we're talking terminology, know that these terms get thrown around interchangeably, but they really aren't interchangeable, but they do have some commonalities. And some of those commonalities, first thing we're going to talk about is freeze-thaw cycle and de-icing chemicals. The two of them are tied hand in hand. Why do we put air in our concrete? This is not good. To give the water a place to expand when it freezes. Perfect. I know you all knew that answer. You're just in food coma. So I will chalk it up to good lunch that you all didn't jump on that answer. But yes, this is why we put air in our concrete, because when it freezes outside, water in our concrete expands. It needs somewhere to go. I already told you that the internal tensions and stresses in concrete, we don't like them, right? So if we don't have a place to go for that stress and that expansion, our concrete's going to crack and it's going to break apart. Okay, so that's why we put an air void system in our concrete to help relieve that expansion for the water that's in our concrete. This is why in South Texas, we don't put air in our concrete. Okay, I don't have to worry about air. They don't have freeze-thaw cycles. They don't use air entrainment. Okay, so we're lucky to be in the part of the country that probably experiences more freeze-thaw cycles than any place else in the country. The Midwest is awful when it comes to freeze-thaw. How many times do we know that every day we get a cycle, right? It's cold in the morning, warms up to 50 or 60 degrees a day, and guess what? It dips below freezing at night again. We have a lot of freeze-thaw cycles. You'd think, well, Canada, they have harsh winters. Yeah, but guess what? They always stay frozen. So the cycle is what matters. It doesn't matter about the temperature necessarily. It's the cycle that matters. And what I want you to realize is, let's all acknowledge that this last winter was pretty awful. Okay, we had probably one of the worst winters here in our region that we've seen in an awful long time. So when we all of a sudden get a ton of calls about scaling this spring, know that it's not only because we have poor finishing practices or because we have PLC in our concrete. Know that we had a bad winter. Okay. And we probably had more freeze-thaw cycles this winter than we have in a really long time. I saw some data that told me that for 1 month in Kansas City, they had like 50 freeze-thaw cycles in 1 month. That means we had some days where it froze and thawed twice in one day, right? And to compound on top of that, what happened this winter when we have freeze and thaw, and we got snow too, right? And we got ice. Guess what happens? It sits on your concrete, okay? And during the day, it melts a little bit, right? Great. But guess what? It literally freezes on your concrete again. So we still have this moisture, extra moisture available, not only in the concrete, but now on the surface. That not only is the concrete experiencing freeze thaws, but directly on the surface, we're literally freezing ice and melting it several times during the month, right? Or several times a day. Okay, that is the worst case scenario. Any ponded water or moisture on your concrete that experiences freeze-thaw cycles is the worst for your concrete when it comes to freezing and thawing. Okay, so that middle picture is of de-icing chemicals or de-icing salts. How many of you have gone out to a job, specifically driveways get a bad rap, right? Driveways are the ones that we always go out and troubleshoot the most, I feel like. How many of you gone out to a job and that homeowner swears up and down that they don't put ice on their driveway or salts on their driveway? All of you? Absolutely. And that might be true. I try to take them at the word and, believe them. But guess where also salts come from? You bring them in on your car, right? And it might not be clear, but some of them are really clear, where you have severe scaling right in the wheel track or severe scaling right where your car parks outside your garage door because your garage is too full of junk that you can't park your car in there, but it parks right outside and it scales really bad right there where the apron goes into your garage. Exacerbated by salt, okay? The penetration of salt. Now, could there have been poor finishing practices as well that weaken that top layer and weaken that surface of your concrete? Absolutely. I always feel like when I troubleshoot a job, it's never just one thing. I wish it was because it'd make it way easier. But it's always a combination of things that have maybe multiplied each other. But absolutely, salts play a chemical or play a role in your concrete. How do we keep that from happening? How do we keep those salts from penetrating our concrete? What do we do? Seal it. Who here knows of residential driveways that get sealed like they should? Yep, exactly. Nobody raises their hands. Okay, unless you are a concrete guy and you pour a new driveway and you do it correctly. Okay, so it is hard to get contractors, builders, homeowners, those kind of things to sometimes buy into the concept of sealing a driveway. And we need to, as an industry, continue to push that direction. I have been out on a lot of jobs too, that when I talk to a homeowner, for instance, and say, hey, your concrete should be treated like a baby for 2 years. That's my theory, right? I have a little picture up here of a little toddler walking in fresh concrete. I want you to treat your concrete like a baby, but don't let your toddler walk in your concrete. Those are two different concepts, okay? But treat your concrete like a baby for 2 years. That means for 2 years, I need to really do everything I can protect it from not only freeze thawing directly on the surface, but ingress of salts, okay? That means sealing it. Now, there's lots of different ways to seal it. People use integral cure and seals, right? Some people use integral sealers that come in your concrete, already in your ready-mix concrete. Some people use topical. Some people use topical that's acrylic versus silicone silane based. Like all these different options are out there, okay? Just know that sealing it is important, and that keeps that ingress of chemicals out of your concrete. Anybody have a sealer that they like absolutely love, that they're like, hey, this really works for us? No? Yeah, some of you. Chaz, do you mind sharing it, or is that something you need to keep proprietary?
Sure, it's K590. I use it on my personal driveway.
Okay. And it's an integral product that you put in your ready mix, or is it a topical? It's a topical. Okay. And it's acrylic based, silicone, silane based. Okay. So one thing about those, they're penetrating, right? And we really penetrate the surface and we densify it as well, which really helps. Does the water beat up on it? Is it a little bit of a waterproofer as well?
Yep.
Yeah.
And you
Okay.
can tell, like when it rains, my driveway would be a lighter color than say the neighbors because
Hasn't penetrated.
It's not absorbing the
Yep.
water.
Yep. Exactly.
Saturating.
Exactly. So I'd encourage you and some guys tell me that there used to be a Blue Ribbon driveway program in Kansas City. Does that recall anybody's jog anybody's memory? Okay. So correct me if I'm wrong, but it used to be, hey, when we put out concrete to homeowners or to residential contractors or residential jobs, it came with a list of this is what you must do, right? You must do these things for me to then come back out and talk to you about your concrete if it fails, basically, right? And one of those things was absolutely sealing it and keeping on a sealing schedule. And I talked to a lot of homeowners that say, if I would have known that that's what I needed to do, I would have done it. So we in this room that we need to do it. How do we get that message disseminated out to the right people? I don't necessarily have an answer, except that we just continue to talk about it, right? We continue to talk about it and hopefully trickle down, right? Because I know a whole lot of homeowners that they build a $1.5 million house and their driveway looks awful and they're pissed. I get it. I understand that. But if you go up to them and say, hey, here's the science. I'm here as an engineer. I talk to about the science, right? That's my job. I tell them why it happens. And if they say, hey, if somebody just would have told me that I need to, applique, roll on a sealer or spray it on, or I need to power wash my driveway twice a year and roll this on, and then maintenance schedule every 2 to 5 years after that, I would have done it. That's not a problem. So we just need to get that information out there, and that'll help with some of these issues. Okay. Now, that doesn't make up for poor finishing practices. We still have scaling that happens when we finish water into the surface or overwork that surface and cause that surface to be weakened, right? We increase essentially the water cement ratio in that top 16th or 8th of an inch of your concrete, weakens it, and it then becomes more susceptible even to these salts. Okay. If you do have de-icing chemicals, I like to remind people, like, power wash it off or wash it off. Or if you have ice and snow that you scoop off your driveway, but it hangs out on the edge of your driveway because you don't scoop it off all the way, take that extra time, scoop it off, then you won't have the scaling on that edge of your driveway. I don't have any downsides. Does anybody have downsides?
They can discount.
Discoloration. Okay, thank you. That's a good one. I don't know why that didn't.
And they probably get acrylic ones that are surface sealers. I've also seen in mix of all these, bad surface issues, sealers that are not bonded. You get a look like you can actually go and you can strike it with a razor blade and lift it off with a piece of tape or something, where it just
Okay.
It was applied in a way that didn't
Bond
to
for
the
some reason.
surface.
Yeah.
That-
Right. The discoloration, you're absolutely right. That's a good one. And with cures too, discoloration sometimes happening with curing as well. And I will say, Joe mentions about peeling off. I have heard finishers that like to use an integral, and when I say integral, in their ready mix delivered to them on site, they like to use an acrylic-based cure and seal combo. They find that acrylic-based protection for their sealer isn't lasting as long as it used to, right? So the problem with the acrylic is you can't apply anything topical once it's already in there, unless it's acrylic-based as well. And they're finding that doesn't last as long, as from what I'm understanding. So they have to come back in, do topical sealer in a shorter, instead of lasting for 2 or 3 years, they have to come back and apply it more soon or more quickly in a shorter time period than that. So I am really, when it comes to sealing, penetrating siloxane, silane based sealers that are applied independently, I feel like do a really solid job. And there's tons of stuff on the market. You just need to know how to use it, how to apply it, at what application rate, and when to reapply it, right? The maintenance schedule. We don't apply it once and forget about it for the next 50 years. Okay. But definitely encourage you to go that direction. Any other questions? Good question about sealers. So, and the discoloration, I struggle with that a little bit too. Concrete's gray. It's a shade of gray, might be beige gray, might be dark gray, might be light gray. So I sometimes struggle as an engineer, technical perspective. You call me and complain about the color of your concrete. I'm like, it's concrete. It's going to have different colors. I don't do that, but in my brain, that's how I want to answer those calls. Okay. But I understand also, if I'm buying $1.5 million home and my concrete looks like a zebra, maybe I'm not going to be happy with it. Or maybe I go and I stain it different colors to make it look even more cool. I don't know. Always thinking outside the box. Couple other mechanisms that I want to talk about. Finishing water into the surface and some improper finishing tools. So we want to float concrete before our water comes to the surface. Although we talked about not being able to close the surface up, I don't want you to wait until the bleed water comes to the surface to then float it so you can close it up easier. This creates another problem, right? We're just creating a weakened plane, like I said. So I hope this doesn't happen. I want to solve the issue of you not being able to close it up with a bull float before you solve it by just waiting for the bleed water to come up and finishing it in. Okay? So I don't like to see that. And I'm a good Catholic, and I like holy water and like to be blessed like the rest of us. But that is something our concrete does not need. It does not need to be blessed at any point in the process, whether we're bull floating it, whether we're finishing on it, or whatever we're doing. Power trawling, we don't need blessing. We don't need a guy out there with your spray bottle in front of your power trawl spraying it down to create a cream surface. Okay. Because I guarantee you do this, it's scaling. I don't care if you cure it. I don't care if you seal it. I don't care if you have the most mild winter in the world. This will cause your surface to scale. Okay. And although I can tell you that the long-term durability of that concrete, it's not structurally damaged, I can tell you that the durability of the surface is trash, right? And so that plays into now all of a sudden our life of our concrete is no longer 30 and 50-year design life because our surface is trash, right? So this extra water on the surface really is detrimental. So all the things that we've talked up to about this point, about changing different things and thinking outside the box to get you to a point where you have some concrete that you don't feel like you have to do this to is our goal, is my goal in the cement world, is a goal from a ready mix perspective. But you also know that you have guys that pour extremely wet and you have guys that will do this no matter what. Okay. And those are the ones that this is geared towards. Okay. Still happen out there that we don't want to use. What is something we absolutely do not want to use on our concrete? What kind of tool do we not want to use? Yeah, Fresno and steel trowels, right? Absolute no-nos. Okay. What they only do, they densify that surface like crazy. They beat it up like crazy. Not only do they knock the air out, which is another thing in our environment. We talked about petrography earlier. And you can do a petrographic analysis on a core that has scaled, and it could tell you the rest of your mix has good air. It has, let's say, 6.5% air, okay, which is what we need for good freeze thaw durability. You look at just the surface portion, and it'll tell you it's got 2% air in it. Because guess what? We've worked the crud out of it and knocked that air out. Okay, so not only have we densified the surface, we open ourselves up to delamination, we've locked in the water, caused the water cement ratio to be worse, but now we've knocked out the air, the other thing that prevents from freeze thaw. So it's like triple whammy. Your top's coming off. Okay, so that's the mechanism on how that works. Just some pictures of good practices. How many? Do you know who I get the least amount of scaling calls from? 2 categories in my repertoire of concrete that I look at. What are my 2 categories that I probably get the least amount of scaling from? Calls. Mainline paving. Any kind of paving that goes through a paving machine. Guess why? They put the concrete in the machine, they lay it down, they vibrate it a little bit, they strike it off, they put their broom finish on it, and guess what they do immediately after that? Double layer of curing compound, and then they don't touch it. Or bridge decks, double layer of wet burlap curing. Mainline paving, because we don't touch it. And the less we touch our concrete, the better off we're going to be. Okay, so that's my first category. What's my other category you think I don't hear from very often? My decorative guys. I don't have a single decorative concrete guy, finisher, contractor that ever calls me with scaling issues. You know why? They don't mess with it. They've got their timing worked out. They cure, they seal, not only to protect their color or to protect their stamp design or whatever, but I don't have decorative guys that call me either. And that just tells me when it's done right and it's not overtouched, I really reduce my likelihood for this to happen. Okay. And once again, I always have somebody in the room that says, I swear, I promise, I do it all right to the best of my ability, right? I do the absolute best I can and I still have issues. And I say, I'm sorry. I wish that wasn't the case, but it still happens. But I will tell you that from my experience, those are few far of what's happening than the guys that are doing it wrong that are causing us our issues. Okay, does that make sense? So my last little tips, I guess, here for finishing. The bottom one, like I said, the more we touch it, the more it's liable to go wrong. I can't remember the wording, but it's really good. Somebody told me once, concrete is going to be the best it's ever going to be as it's delivered to your job site. Okay? Whenever it gets laid down, we only can screw it up, from there on out. And we only can make it worse, right? It doesn't get better. Or I go out on job sites and they're like, oh, you gave me bad concrete. I'm like, well, do you think structurally it's good? You know, you're just not happy with the scaling or whatever. They're like, absolutely. And I said, well, I don't care how good of a ready mix producer you are. You can't bring me awful concrete in the top 1/8 inch and give me 3.5 inches of that. That's wonderful concrete. I don't have any magical like that happens. So we can only make concrete worse in the field. It gets worse when we overwork it and touch it too much. Brooming, I've had some issues with some brooming and just some timing. I'm a fan of brooming. You know, we typically can't overwork it. Some paste on your broom is good, but if you have a lot of paste, even if you think it's done bleeding, it's not ready. So just be aware of that. And I've actually had some instances too where brooming, you know how everybody broom, swoop, swoop, and then dunk in the bucket, rinse off their broom, swoop, swoop, you know, we get some bucket dunks. You would be surprised that I've had some jobs that when I have a broom pass right after my bucket dunk, not only do I have discoloration in the broom marks, I can see the discoloration as my broom gets more dry, but I can also see scaling in a really wet broom on the first pass and no scaling on a drier broom on the passes after that. It's crazy. It's like, can see it visually, can see what happened. So even a wet broom or an overly wet broom can cause you issues. So just know, once again, everybody's shaking their head like, we didn't used to have those issues. You might not have, and I'll acknowledge that. But we now have to be extra cautious and take into those kind of considerations. And I'm a fan of finishing aids. There's a lot of finishing aids out there, both topical and that can be put in your concrete and used on a job site that will help with some of these finishing issues and definitely keep you away from that extra water. So those nanosilica or colloidal silica based products, whether they're a topical one or one that's put in your concrete, I think those are great technologies that are out there now that we need to start utilizing and can be really helpful, especially keeping it off the water bottle and the hose. So that's the end. Questions? What do we think? Anything specifically about scaling, since that was our last question? Yeah. Super salts. Yes, they're calling them super salts. I'm glad you brought that up. I don't know. So who has heard that term super salt? Yeah? Okay. So, and please speak up because I'm not super educated on it yet. I'm just coming familiar with this term, but it's basically a combination of salts that they're now blending together, that they're basically selling it on the fact that it goes to colder temperatures and it works more efficiently at colder temperatures and works more quickly. That's kind of the sales pitch for these super salts. The problem with these is they are very aggressive on concrete and they attack concrete in more than just one salt component, right? Like we are attacking it in different chemistry buckets that are really eating away concrete. What do we do? I don't know. Protect ourselves as best we can with sealing. But yeah, these are becoming a real issue. And I think it's important to get the message out there to homeowners that go to Lowe's and buy these and see the flashy thing that says, oh, it's good for minus 30 degrees and it melts it in an hour or whatever. Like, I don't know what the sales pitch is, but try and put the word out that says, hey, these really harsh materials are going to wreak havoc on your concrete. And if you put them down, get them off as quickly as you put them down. I don't know. Does anybody have better expertise in that department? But it is becoming an issue. Oh, okay.
But we also try.
Literally the valve fins,
Really?
everything we had to buy, we bought back to steel.
Crazy. And yeah, DOTs and municipalities, like switching over to these kind of things and putting them down on their roads is going to be um, very harsh. Overland Park did a study, they did a roundabout or a section of concrete that they put down that said, we're not putting anything on it salt wise for 2 years. We want to see if this salt thing really flushes out. We're not going to put any de-icing chemicals except for sand on this piece of pavement. I think is a roundabout and the feeders into it for 2 years and see what happens. And after their 2 years, there's no scaling, there's no issues. They're super happy with it. And to them, it proved to them, at least the city of Overland Park, that says, oh, there is really legitimately something behind this salt scaling concept that we really do need to do a better job at limiting our use of that. But as far as these super salts, any other insight or experience with those? I know we just talked about it last week with the concrete promotion group there in Kansas City. It was a topic that came up that they're like, hey, we're going to have to start talking about this as an industry about how we combat this or those kind of things because they're much more aggressive. Yep. Yep. Yeah. Right. Yeah. Yeah. Scaling is not a new concept. The mechanism of how it works, also not a new concept, right? We had scaling before PLC came into the market. Um, and we had issues with freeze thaw and de-icing chemicals and all of these kind of things before PLC. So whether the extreme amount of calls that we seem to be getting now is more attributed to the really harsh winter that we had. Because I'll tell you what, I didn't get all these. We've been on PLC for 3 years now, roughly. So this spring, I definitely have had more scaling calls than I had last spring. And I know last winter was not as bad as the winter that just came up. And we were pouring concrete with PLC then. So does it all tie in and play into each other? Absolutely. Is it only finishing issues? No. Is it only de-icing chemicals? No. Is it only PLC? No. I think it's the combination of all of them. And when they're used in combination and some things get abused, then we have an influx of issues. So that's why it's important to go back to the things that we know help prevent it and make sure we're doing all of those right. What else? Questions. Did we learn anything? Did you learn anything? Like, hopefully you learned something, at least to think outside the box, at least to give you some knowledge to start having these conversations with people down the chain from you, whether that's owners or concrete contractors or finishers or homeowners. We all need to do our part in our little wedges of the business to continue with this message down the line that says, PLC is here to stay, no matter if that's something that you agree with or not, right? That's a whole nother debate that we can have. But it's here to stay. It's not going anywhere. And we need to start thinking outside the box and getting back to the basics to help us manage some of these issues that we're definitely having. What else, gentlemen? And Emily? You're welcome. Hate to lump you in. This is normally the dynamic, right? Is so like the gentleman comment typically works, but so otherwise, that's the end for me. That's enough talking from my loud mouth. Yeah, I had some troubles yesterday and I couldn't get this presentation sent to Emily. Normally she would have printed them out and given you folders. So that's on me. That's not on them. Yell at me for that. But if you want this presentation, I know Emily just recorded it, I think, so it'll be available that way. And if you want the slide deck or the PDF of it, just either leave me your business card or send me an email or something, and I will send it to you. Happy to share this. There's nothing proprietary in here and not information you can't find on the internet, but I've collected it all together for you in one place at least. So I'm happy to share it if you'd like it. Yep. Thanks, everybody. Yeah, you're welcome. It's let me put it back up here because it's easier for you to read off than it is for me to tell you it and copy it down or take a screenshot of it. There, can you see that?
I definitely will.
Okay, perfect. Yeah. Okay, good. I'll send them to you. Oh, you got it. Got it. Good. So when I talk about these kind of things, like when I go troubleshoot, scaling, plastic shrinkage, these kind of things, the CIPs from the NRMCA that are free to download PDF, they're not free to print, but they're free to do as a PDF. Yes, absolutely. Shoot me an email. Or yeah, those are great. Yeah, they're a front and back.
Yeah, we're under that 4.0.
Yeah. And they're a great thing, not from you, but from an industry-wide thing that's recognized that I hand and leave with people and explains the mechanisms to how this happens. Yeah. But yeah, either get with guys at MCM or email me and I can get you the ones that I use the most often. Scaling, plastic shrinkage, curing, some of these other ones. Yep.
Thank you.
Yep.
No problem. Yeah.
Perfect. Yep. Absolutely.
Please.
Thank you. No, this is great. Thank you guys. I normally didn't have my ducks in a row.
Question on your steel. So if I hit it, say twice with a Fresno,
Yeah.
wouldn't that be better than hitting it 10 times with the Darby, the magnesium though?
Oh Lord. I don't know.
That's where I'm struggling.
Yeah, okay, I get you. I don't know. Yes, thank you. Dang it, I don't know if I have a good enough opinion on that. Right. But you do on
personal stuff. I use a Fresno all the time because it's fantastic.
And you feel like it closes it up so much quicker.
Yeah. So good. Dude.
I wonder why do we think I'm gonna ask you a question. Why do you think it closes it up quicker?
I don't know if it's the weight of it. Fresno's really light.
Mhm.
I have really light.
Like a big one.
It goes across that tight. Yeah. Versus a wider edge.
Like the edge on it is better.
It's tighter. Like the knife.
2 times with Fresno and it's beautiful. We're all just sitting there working with my man.
Yeah.
And you crazy work it.
Yeah. So I'm just like, I know
Okay.
I heard it there.
I've never had somebody explain it to me from that perspective before. Thank you.
Yeah.
I really have not. Thank you. Yeah.
One of our exterior guys reports a lot. I'm not disagreeing with you. You've been doing it for 30 years, but it might bite you. Say do not put steel on it or over
Yeah.
top. But
I even come like on sidewalk on cool crowd versus magnesium Darby. Just because it's so much faster. Nice.
Yeah.
I've never had anybody explain it to me that way. I now am going to dig into that. That's interesting. Thank you. Yeah. Yeah.
It was a good presentation.
Thank
It's
you,
good
sir.
to see you.
Good to see you.
But there's one thing.
Yes, sir.
In the 1980s, they were still preaching the same things you said today. But anyway,
Isn't that terrible? We need to come up with new material. I feel like an old comic can't come up with anything new.
it's the contractor's problem, and he just it's the golden rule. He who has the gold rules, and so it all flows
uphill
back to us.
Yes, sir.
You're a good.
Thank you. Thank you.
So my only question is with customers having these problems.
Yeah.
My question is, and they ask me, I'm trying to prevent it, but it's scaled.
Yeah.
Now what? It's like, I'm like, you have good concrete here.
So what do I do?
It's like, you tell them, power wash it and put the Sloxine sealer on it. It's
Yeah.
gonna look ugly, but
Yeah.
at least nothing can come further.
Right.
Or
So
like grind it or popping mix.
So I am never a fan of trying to top it. we got to clean it. We got to clean it first, right? Before we top it, we got to get all that junk up, right? Everything that's going to potentially pop off, maybe the whole thing, right? So you got to have really good surface prep. And then you got to have a good bond. Sometimes I'm not a big fan of cement-based bonding topical additives because they don't bond as well as good. Sometimes epoxy-based things work, right?
Yeah, I see a lot of them that like
right.
Top and patch.
And if it's just a small spot, right, I'm okay with that. I'm never a fan of remove in place. Not only is it costly, but frankly, you could end up with the same issue, right? It could or it would be worse, right?
Well, that's the thing. Like, you've got a parking lot in a retirement village, which they've oversold. It cost it. They never sealed it. When I first went out after the mild winter, I said, clean this off. This is the area they walked that they've salted.
Yep.
Clean that off, power wash it, seal everything. They didn't. Then this year, he's like, the entire parking lot, all the walkways, everything. I'm like, same contractors. They're
I just told you.
And I told you last year, you gotta get sealer on it.
Yeah.
Oh, I think they did. No, they didn't.
Yeah, no.
So I'm like, and he's like, whatever I do, I got this thing with the state. I have to have a warranty for so long and blah. I'm like, I don't want to tear it all out. I'm like, okay.
So here's the other thing that people are hesitant to do, but works. And the reason I like to suggest it is because when I do have mainline paver issues, like at the Kansas City airport, I had some stuff that got scaled. Guess what they do? They diamond grind it. No, they diamond grind it. And then they seal it. And so diamond grinding, and you can diamond grind it to a finish that you want, right? It doesn't have to be a rough diamond ground texture, right? You diamond grind it and then you put a buffer on it and you buff it and you get a nice texture. And then you seal it. And do you have the same concrete look? No, you get a little bit more exposed aggregate look. But can I tell you, you've taken off that surface? That is the problem. Absolutely. And can I tell you, we're not going to have the problem anymore? Yep. So I'm a big fan of diamond grinding, especially when we're talking about more panels in your driveway than not. You know what I mean?
It's even more fancy.
Yeah, I don't have a problem with the look of it. And normally when I suggest that, I try and take a picture of a diamond ground surface with me, right? Especially if I know I'm going out to look at a scaling. And then I show it to everybody and they're like, oh, okay, that's not bad, right? It's not ugly. There's costs associated with everything, but I'm never a fan of remove and replace. And I think with these scaling issues, this diamond grinding is legit remediation.
Yeah, because that's where I'm at. I've got 5 of these that are coming over and my name's getting all of them. Like, well, I'm not just going to send you free concrete.
No.
And
no. Diamond grinding is a legit idea, and you can grind it to whatever kind of texture you want, you know, and you've gotten rid of your issue, but we still need to seal it after that, right? We still need to protect it because now we've exposed it even more. But so sealing still needs to happen. At least we've gotten rid of the stuff that's going to keep coming up. So, yep, absolutely. Hey, stranger.
For doing that.
Yeah.
That was great.
How are you?
See if I can get it.
Yeah, absolutely. Yeah, I'll send it to you. Yeah, no problem.
Yeah, that's
for sure.
I'm glad thanks for taking charge and doing something we can.
We're trying. I guess we got to get out there and talk about it, right?
It'd be nice if there's silver bullet solution. No problem.
It's been a month ago that guy's like, why can't you just give me the recipe and just tell me what's going to work? I was like, oh my God, you don't know how much I wish I could do that.
Oh,
you know,
it's like that with a lot of anything in concrete. I get complaints about air issues.
Yeah, right.
Well, there's a million things. I wish I had an easy answer for you.
And I think the terminology he used was like, I just want something that's dummy proof or foolproof. And I wanted to jump all over that and be like, well, maybe that's part of our problem. We can't, dummies and fools, we can't be placing it, right? But I didn't. But the inner angry girl of me wanted to say that. Yeah, exactly. Yeah. So, no, we just need to keep getting the message to the right people.
Yeah,
the right people.
We're working on it.
Yeah,
it's all a work in progress.
Thank you for doing it.
You're welcome. Absolutely. No. Yeah. I feel like I've been, I feel like I've been talking, like, I feel like I've heard you talk about PLC for the last 3 years. And I was like, you have.
Yeah.
But it has, the talk has evolved from, hey, here's what it is, how we manufacture it. Here's what the strength profile looks. Now it's like this whole other, like, well, here's the problems we're having and how do we address it? So yeah, it's like talking about the same thing, just from a different perspective.
Yeah.
So,
Well,
but
it's
we'll,
still the hot topic. 3
I
years
know,
later.
3 years later, who would have
Still
thunk?
the hot topic.
Who would have thunk? We'll get through it. And not that it warms my heart, but we're all having the same problem. So
No, that's true.
it kind of does warm my heart a
I
little bit.
point that out to our people sometimes.
Yeah,
It's like,
yeah.
because you hear complaints from customers. And think,
Yeah.
well, this is not exclusively like one
Right.
supplier. That's
Right.
having an
Yeah,
issue.
exactly.
It's kind of an industry.
It's an industry-wide and countrywide thing. Like I can talk, the only guys that I don't talk to PLC about within my network are the guys in Nevada, because they're not really producing it because they don't have to because of the imports. Same thing with the guys in Texas. They're not producing it because they don't have to, because none of the imports are that way. And so they have to, otherwise all my other counterparts I talk to across the country, same issues. They're struggling here and there with these same kind of things. So I don't like everybody that's struggling, but it makes me happy that it's not just me. As morbid as that sounds. Yeah, exactly. We're all rowing the boat in the same direction. Maybe not as fast as we'd like, but we're all. No. That's people ask me that. Be like, when is it? Well, when is the number going to go up from 15? And I used to say, well, it's going to go up sometime. I don't know when, not in the next couple of years. Lord, I hope it doesn't go up till I'm retired.
Yeah, let somebody else
right? Send it out to somebody else. Exactly. That's my better be 40 years down the road.
He's too young. It's gonna get him.
Right. Yeah. Yep. It'll catch him on his tail end. Yep.
That's the one thing about being in control,
right? Right. Yeah.
It's like Dave Sikorsky would say, send me a postcard. You know how that works out.
Right. Like Dave's like, got out of this at the right time. Yeah. Exactly. Yep.
Thanks again.
Good to see you, Bobby.
I just have a curious question, and you want to have an answer for it. I'm new into the concrete world.
Oh, okay, cool.
I'm an oil field guy. So,
okay. Oh, well, welcome to the concrete world. I don't know if it's any better than the oil patch.
No, it's good.
Yeah. Okay. Okay. Yeah.
But so I just had a whole concrete shop.
Okay.
And I'm so confused on epoxies. Do you
epoxy.
look at anything that bonds better? That's because now they keep now there's just new advertisements for X brand, and now a new style that's a different acrylic.
What do you want? What do you want to do with your epoxy? What is your goal in using it? You just want a surface covering?
I'm really wanting it to just seal so it cleans. I don't really care if it's purple and green and black, whatever. I just want it to where I'm working because I've got a few lifts and I do a lot of car work.
Right, and you just want something that maybe is easy to clean and doesn't penetrate. Okay, so brands, there's so many on the market, it's overwhelming. What I'll tell you to look for is something that says penetrating. Okay, words like penetrating or silicone, siloxane based type of products. And then they have things like densifiers. So all of those are going to make sure you've got a good solid bond. I caution you with words like waterproofer. Okay. Although they have waterproofers out there, absolutely.
Sure.
That'll help you beat up oil or water or whatever on the surface, which would be helpful for you to put down some oil slick when it does. You don't have any penetrate. I would be cautious because one man's waterproofing is not equal to another man's waterproofing. Does that make sense?
Oh yeah. Oh,
so do a little bit of research there, but definitely look for something that is penetrating because it makes sure it bonds more than just the very surface. It actually penetrates into your concrete and that densifies and is a siloxane silicone based.
Because that's the new one I've heard that they're now coming out with for like a 2-stage.
Yeah. So now downside, they're also top tier, more expensive. Right.
Well, I'd rather do it once than
where those acrylic ones are more cost effective. But I'm kind of in the same boat. I'd rather pay a little bit more and only have to do it once than have to come back and reapply or those kind of things.
Yeah, the worst thing is like emptying the whole shop, right? What do you do with a 60 by 80 shop? You move it all outdoors and pray it doesn't rain for
and
4 days that you get it done.
It's not a one-day project kind of thing. Exactly.
Yeah, and I've tried the whole. Our last house in Colorado, I did work. We moved everything to one side, did one side, and you move everything back to the other side. And it's just, just a nightmare.
Now I will tell you this: in the future, if you do those kind of applications, I would encourage you to look at stuff that is in your concrete that the ready mix producer can put in at his end. They do have good waterproofers. Zypex and some other kind of things, but they do most of these ready mix size, maybe not your small producers, but any of your mid-sized to larger producers will have something in their toolbox for these kind of applications, like a waterproofer and something like that will help beat up that material on top, which will give you that extra layer of protection.
If you get that,
so-
does that help? Does that not help the Hierman of
the steeling. So that's this
steeling?
question. So it depends on what you're using in your concrete, what you can use on top.
Okay.
So that's just a question you'd have to ask. Because for instance, you use an acrylic base something in your concrete, you're not going to get a penetrating, sealer on it. Acrylic goes with acrylic and these kind of things.
Yeah, like water-based, oil-based.
Right, exactly. So you just need to make sure, which is so hard. How, as you as a owner or a person, like, how do you know what questions to ask? You don't, which is the tough thing in our industry. But I encourage you to look that direction too.
Okay.
If you do it again, and just make sure that if you do that, make sure you've talked about what's the next step to make sure it's compatible with what they're using. Yeah, I just
You did fine. You didn't have to go fishing too, Hank.
so embarrassing. I can't believe I did that in front of all you. And it just was a natural, it was like a natural reaction. And then I realized I was in front of a group of people. Why did I just look down my dress?
You're all right.
Anyway, it's at least a group of men. Yeah, what are you gonna do? Shit happens. Whatever. I guess, it's just me. I'm a little rough around the edges. I can't hide it. I'm just country. I can't hide it. What are you gonna do? Yeah, that's what thank you. Thanks for turning that negative into a positive, Joe. That made me feel better. Thank you.
Yeah, thank you
But
for the
yeah,
information.
Absolutely. You're welcome.
I was actually kind of curious if you knew where that bleeding's like came from.
Oh, the water one?
With the water going up and the water going down and the little crack and
No, did you make
years ago.
really? No, I do know where it came from on my end, from some Lafarge presentation that I had in a stockpile, and I've used it for years. You made that?
I did.
Oh my God, Joe, that's amazing.
I'm
gonna start telling people that.
Don't.
Yes.
And
Like,
one of
hey.
the other pictures was funny too because it was actually we miscalled it though. Dwayne texted me while it came up, the one with all the bleed water with the bull float.
Oh, uh-huh.
I've got that one actually came from Marshville, Missouri. That was one. He thought it was. I've got another slide with when we were in their bins out in Pittsburgh, Kansas, and it was raining. That's how I know that was different because that one the sun's out, you can see it.
Oh yeah.
But there's another one that looks very similar.
Similar to that?
You can actually see the guys.
Yeah.
It was pouring down rain.
And
they were pouring the bins.
and all my pictures, like, well, unless they're like little emojis or whatever, like they come from some presentation that somebody else has done that I totally. Yeah. No, but that slide there, because it's good.
Yeah,
I love it.
that was
Because it's simple and to the point.
It's held.
And it's still the same thing. No, I love that. That's
And you
awesome.
have the other one that goes with it,
Oh, what's the other one that goes with it?
evaporation retardant.
No,
So
probably
it's the
not.
same slide, but I've got little bubbles of
Oh,
monomolecular film that goes on.
really?
top and-
Oh, I'm gonna have to dig through my
I-
folder of
Yeah.
presentations. No, and I maybe have never used it.
That's my follow.
Love that. Oh, what a small world. We just kind of.
About it all the time. Although it sometimes it comes back and bites you because I can remember doing all of wrestling years ago. He threw up one of my pictures and whatever he said wasn't. No, wait.
It was
that's not what that
misinterpreted.
was.
Oh,
That was not what that was.
right. You like,
But,
yeah.
Whatever. You use it and it works.
yeah, but at the end of the day, you're like, actually, that's not what happened there.
Actually, I know exactly where that was.
Yeah. Oh, that's funny.
I like that pop-out picture that everybody's used here. And somebody told me
That's in
years ago,
PCA. That one is like, I think in PCA or something. That one.
I think Dave Sikorsky told me that was his pin, or that was at least I can't remember if he said it was his pin or if it was just an Ashgrove pin.
Oh, okay.
In that picture,
In that picture.
everybody has used forever.
Forever. Yeah. Like, cause it really does. It's like super clear
Oh, yeah,
and you can
perfect.
see the shape and it's like, yeah. That's funny.
I actually that was one of the parts I thought was making that distinction of this is something different.
Yeah. It's,
Don't look at this and just go, oh, my surface is coming off and it's because of this. No,
Right.
this is different than this.
It is
This
different.
than this.
yeah. Because how often do you get those too? It's be like, well, and I was like, and you get out there and you're like, that's actually not what happened here.
Yeah.
Right. Or it's, it's something different or it's, Yeah.
That's what drives me nuts about the online forums and stuff. There's so many pictures that you look at and everybody's, oh, it's this, it's this, it's this. You know absolutely nothing about what you're looking at.
Right.
You don't know what it's poured at. You don't know what the air content was.
There's no
You don't-
context.
There's no context whatsoever.
Right.
And you're not
Right.
even know what you're looking at.
Right. Right. And I have customers that do that, and so do you, I'm sure. Sends you like eight pictures of something,
Yeah.
and they're like, "What do you think?" I'm like, "Okay, I will look at the pictures, but here is my form list of questions that I'm going to ask before I even like give you a remote idea of what I think."
Yeah. Before I even try to throw.
And don't send me a zoomed in picture
Yeah.
that shows me this side. Like, fine, send me some of those, but I need
I
a
need to know what I'm
complete
looking at.
full story.
Yeah.
Not just like, here's what I'm looking at, business size.
Same boat.
Anyway, yeah. But oh well, what are you gonna do?
Happy trails.
Happy trails. Have a good weekend. Talk to you later.